Namaste. In this video, I'll be explaining to you the core components of Apache Storm framework and how it is used for processing stream data in real time with the help of case study and also comparison with Apache Hadoop. Apache Storm was written in Java and Clojure and created by Nathan Mars and team at Backtype, which is a social analytics company. Later, it was acquired and open sourced by Twitter to process in parallel real-time stream data. It is easy to set up and manage a distributed environment and cluster state via Apache Zookeeper. Very useful as it is a simple, free, open source for easy to set up and process real-time stream data in any programming language. Storm topology consumes stream by repartitioning as per need to keep up performance even under increased load by adding resources linearly. It is horizontally scalable as it can be installed in many systems and provide guaranteed data processing even if any cluster nodes die or messages are lost. It is a fault tolerant with no single point failure and has very low latency. It could be utilized in small companies as well as large corporations. Let us understand the cluster-based Storm architecture. Cluster has two types of nodes. Nimbus has master node and supervisor are working nodes. Storm topology is analyzed using Nimbus to gather the list of tasks to be distributed by all supervisors to one or more worker processes, which will spawn as many executors as needed to run the task. The communication between Nimbus and supervisors happens through an internal distributed messaging system to process real-time data based on concept of reliable message queuing. The messaging patterns follow the public subscribe pub/sub model where publisher are message senders and subscribers are message receivers. Spot will read the data from messaging system and convert it into tuples and input into the Apache Storm. Messages are queued asynchronously between client applications and messaging systems. A distributed messaging system provides the benefits of reliability, scalability, and persistence. Core components include Nimbus supervisor, worker, process, executor, and Zookeeper framework. Master node runs a daemon called Nimbus, which assigns tasks to all worker nodes and monitor failures. Each worker node runs a daemon called supervisors, which completes the assigned task with the help of multiple worker processes. These worker processes create multiple executors to perform a particular task. An executor is a single thread spawned by a worker process and it runs one or more tasks, that is spot or bolt, in a topology for performing actual data processing. I will explain topology in later video section. Nimbus is stateless but not the Storm, as Zookeeper coordinates and maintains states of Nimbus and supervisors as shown in the diagram. This state helps a failed Nimbus to start its work from where it left in the fastest and best possible way. Apache Storm also has advanced topology called Trident topology to maintain state and provides API like PIG. Let us use this diagram to explore the core concepts in Apache Storm. The data source of stream is called Spot, which accepts input data from raw data sources like Twitter Streaming API or Apache Kafka queue. We can write spots to read data from data sources. Bolt filters, aggregates, join, interact with the data sources and databases. Tasks are either the execution of a spot or bolt. A topology runs in a distributed manner on multiple worker nodes. Storm spreads the tasks evenly on all the worker nodes to listen to the job and stop the processes whenever a new job arrives. Tuple is a data structure which with a list of ordered elements. It supports all data types and is modeled as a set of comma separated values which are passed to a Storm cluster. A stream is an unbounded sequence of tuple. Storm provides the primitives of transforming a stream into a new stream. For example, we may transfer a stream of tweets into a stream of trending topics with the help of Spot or bolts. Spot is a source of streams that connects to the Twitter API and emits a stream of tweets. A bolt consumes any number of input streams, does processing and possibly emits new stream. Data stream flows from Spot to bolt or from one bolt to another bolt. Stream grouping controls how the tuples are routed or flows in a topology. There are 4 inbuilt groupings as given here. In shuffle grouping, an equal number of tuples is distributed randomly across all the worker executing the bolts. In field grouping, the field with the same value is in the tuple are grouped together and the remaining tuples kept outside. The tuples with the same field values are sent forward to the same worker executing the bolt. For example, if the stream is grouped by the field word, then the tuple with the same string hello will move to the same worker. In global grouping, all the streams can be grouped and forwarded to one bolt. This grouping sends tuples generated by all instances of the source to a single target instance by picking the worker with lowest ID. All grouping sends a single copy of each tuple to all instances of the receiving bolt. This kind of grouping is used to send signals to bolts. All grouping is useful for join operations. Well, network of spouts and bolts are connected together to create a topology, which is a directed graph where vertices are computations and edges are streams of data. A single spout and an array of bolts are the smallest logical unit of a topology that executes in parallel where spout emits the data to one or more bolts. A bolt can be emitted into another bolt as inputs. Edges in the graph indicates that bolts are subscribing to which stream. Links between nodes indicates how tuples should be passed around. For example, if there is a link between spout A and bolt B, a link from spout A to bolt C, and a link from bolt B to bolt C, then every time spout A emits a tuple, it will send the tuple to both bolt B and bolt C. All of bolt B's output tuples will go to bolt C as well. Storm topology is a thrift struct and Nimbus is a thrift service. We can create and submit topology using any programming language. Thrift protocol was built at Facebook for cross-language services based on remote procedure calls. Now it is an open source Apache project. It is an interface definition language to define new data types and services. In addition, it can perform streaming, messaging, and RPC in distributed applications. Apache Zookeeper is used for coordination between the Nimbus and the supervisors. The workflow of Apache Storm is as follows. The Storm topology is submitted to Nimbus. Nimbus processes the topology and gathers all the tasks and order in which the task is to be executed. Nimbus evenly distributes the task to all the available supervisors. At a certain interval, all supervisors send heartbeats to the Nimbus to inform them that they are still alive. If a supervisor dies and does not send a heartbeat to the Nimbus, then the Nimbus assigns the task to another supervisor. If Nimbus dies, supervisor continues work on an already assigned task without any issue. If all the tasks are completed, the supervisor waits for a new task to come in. The dead Nimbus restarts automatically by service monitoring tool, for example, Monit. Similarly, the dead supervisors also restart automatically. Since both the Nimbus and the supervisors restart automatically, both continue where they stopped. If all the topologies are processed, then Nimbus waits for a new topology to arrive and supervisors wait for new tasks. There are two modes in a Storm cluster by default. Local mode is used for development, testing, and debugging by adjusting parameters. In local mode, Storm topology runs on local machine in a single JVM. In production mode, we submit our topology to working Storm cluster, processing processes running on different machines. Most of the companies are using Storm as an internal part of their system. Some use cases are shown here. Twitter is using Apache Storm for product analytics by processing each and every tweets clicked on Twitter platform. Navisite is using Storm for event log monitoring and auditing systems. Vago is a travel meta search engine located in Singapore. Travel related data comes from many sources all over the world with different timing. Storm helps Vago to search real-time data, resolve concurrency issues, and finds the best match for the end user. Let's take a real-time example of Twitter analysis and see how it can be modeled in Apache Storm. The following diagram depicts the structure. The input for the Twitter analysis comes from Twitter Streaming API. Spout will read the tweets of the users using Twitter Streaming API. an output and stream of tuples. A single tuple from the spot will have a Twitter username and a single tweet as comma separated values. Then this stream of tuples will be forwarded to the bolt, and the bolt will split the tweet into individual words, calculate the word count, and persist the information to the configured data source. Now we can easily get the result by querying the data source. This framework supports many industrial applications. Cloud is an application that uses social media analytics to rank its users based on online social influence through cloud source core. The weather channel uses Storm topology in ingest weather data. It has tied up with Twitter on enable weather informed in advertising or Twitter and mobile applications. Telecom industry process millions of phone calls per second to improve call quality. They perform forensic on dropped calls and poor sound quality. Both Storm and Hadoop complement each other and differ in some aspects. Apache Storm does all the operations and it is not persistent, while Hadoop is persistent and is used for batch processing but lacks in real-time computations. The following list of parameters are used in table to compare Storm and Hadoop. Both are free and open source cluster-based framework for analyzing big data based on master-slave architecture, where master node in Hadoop is called job tracker and slave node is called task tracker. While in Storm, master node is called Nimbus and slaves are supervisors. Apache's Hadoop architecture coordinates without Zookeeper, whereas Storm coordinates only with Zookeeper so far. Nimbus is responsible for distributing code around the cluster. A Storm cluster is similar to Hadoop cluster, where stateful Hadoop runs MapReduce job and stateless Storm runs topologies. MapReduce job executes in a sequential order and finishes eventually, whereas a topology runs or processes messages forever until we kill it. To summarize, Apache Storm is a free and open source distributed real-time stream data processing system. Storm topology processes messages forever until we kill it. It is easy to set up and could be utilized in small companies as well as large corporations, and to make a career in big data analytics. To learn Storm, we require a good understanding of core Java and any flavor of Linux OS. Storm framework is used and powered by many companies like Yahoo, Yahoo Japan, Twitter, Shopify, Yelp, Flipboard, Ola, and so on and so forth. So that's all in this video on introduction to Apache Storm. Learn more by taking up quizzes available on my Google site. Thank you.